Hello everyone, this is Mr. Appel, and we are going to graph this piecewise function, which is not all linear. So this one's going to get interesting. There's three different pieces to this one, three different intervals we're going to look at. So let's start with the first one. The first one here is x squared minus 3 when x is less than 0. And so we're expecting a parabola because it's quadratic. We're expecting it to be open upward because it's just a positive x squared there. But to find some critical points, we're going to probably need to plug in some values. So I'm just going to get a couple of critical points. And so I'm going to make a table here. And so when x is, let's say, -2, so -2 squared is 4. 4 minus 3 is 1. When x is -1, -1 squared is 1. 1 minus 3 is -2. Now, I'm going to go ahead and check when x is 0, even though it's not defined there, because that's one of the dividers between two pieces. And we always want to check both functions at those dividers to see if there's a gap. This one's not going to have a gap. I'm giving you that preview, but the next video I'm going to show you one with a gap so you'll know what I'm talking about. So when x is 0, we get -3. So let me see if that's enough to give me a graph, a decent graph. So 0, -3. I'm going to open circle that for now because remember it's not defined when x is 0. And then -1, -2. -2, +1, and I'm starting to see that parabola going up. If it's helpful to get one more point, put in -3. -3 squared is 9. 9 minus 3 is 6. So -3 is 6. And now we can use our understanding that that's just a parabola. And it's everything less than 0, so it's going to keep going up. Okay. The next interval there is, so I'm just going to change colors. I'm trying to change colors, but it doesn't seem to want to let me do that. Sorry. Why won't it let me change colors? Okay. So the next interval is between 0 and 4. This one's linear, so a little easier to graph. So at 0, the y-intercept is -3, so it turns out that's right there at -3. And then I'm going to use my slope of 1/2 there. So I'm going to go up 1 and over 2, and up 1 and over 2, until I get to x equals 4, because that's the other boundary between the two intervals, right? 4 is the dividing point between those two pieces. So I'm temporarily going to put an open circle there. That doesn't even look like an open circle, so let me fix that. And that one's a straight line, so it's going to look just like that. And now let's graph the last piece for when x is greater than or equal to 4. So this is another quadratic, so you might want to make a quick little table. And again, we want to see what happens at -4. So -4, you can't even see the function anymore. Let me erase that. -4 minus 4 is 0. 0 squared is 0. 0 minus 1 is -1. When x is, oops, I said -4. I meant +4. But I did +4, so that's okay. +5. 5 minus 4 is 1. 1 squared is 1. 1 minus 1 is 0. When x is 6. 6 minus 4 is 2. 2 squared is 4. 4 minus 1 is 3. Let me do one more just so I get a nice clear parabola. 7 minus 4 is 3. 3 squared is 9. 9 minus 1 is 8. And for -1, again, that fills the hole in. So that means this graph's going to be continuous. The pieces all kind of connect to each other. And again, we'll see some examples in the next example where that doesn't happen. There's 5, 0, 6, 3, and 7, 8. And so we can see that parabola going the other way. It's a little hard to tell the curviness there because my graph isn't that great. But that is what that graph is going to look like. So it's kind of parabola curvy over here to the left of 0. It's nice and straight there between 0 and 4 because it's linear. And then it goes back to parabola on the other side. And that's what that one looks like. That's all for now. Thanks.